Alright, this tutorial will be for a, wrong one, will be for a laser cut lantern. This is a Japanese lantern style, where this is one that's going to be made on the laser cutter. The actual design, you can change it yourself. We are more interested in showing how we can relate the Fusion 360 file with the laser cut file, and then how to get a rendering out for it, and possibly adding this light sources if we have time. The first thing we're going to go to is we're going to go to this website called boxes.py. It's a great website because it has, you can plug in some details and it instantly gives you the illistrator file or the SVG file, so you don't have to make all those hinges for your thing. The box that we want for this tutorial is just a fully closed box, so we'll click this over here. I'm just going to pick some dimensions. I haven't done all my planning for my size, but I'm just going to assume my thing's going to be 10 centimeters by 10 centimeters, and I'm going to make it 30 centimeters high. So I'm going to change these values over here to 30 millimeters high. Nothing else here I need to change. I know I'm making it out of 3mm plywood, so I'll have that here. If I'm changing this for whatever reason, like if I'm using cardboard, I'll change this value. Everything else here you don't really have to change. The one thing I would make sure you have is this reference 100 is relevant if you have a weird sized box that you're making with this website. You put that reference 100 it will make a 100mm long element in your thing. So when you put it into Fusion 360 or into Illustrator later, you can measure that. And if that thing's not 100, then the size, there was a problem when it was importing the size. So if you measure it and it comes out as 50, you know you have to make it thing twice as large. Then we press over here, we can press generate. And the website should, over here, it's made all the file for you. This particular one, I just wanted to make a regular box. So this looks like a rectangular prism. It has 6 sides, so this will be the top, bottom, wall 1, 2, 3, 4. And here's our reference piece down the bottom that we can measure to make sense. So we're going to right click and we're going to save it as. And we'll just save it as, what will we save it as? Lantern. The website's on the Google Classroom. So now I'm just going to import it into Illustrator. Let's pause. I just want to make sure. So if you have we have our thing downloaded now. We want to place it. I want to place it into an Illustrator file first because I want to modify it to get some nice looking shapes out for it. I'm going to go here. I'm going to go File. I'm going to go to Place, and I put mine onto the desktop over here. This lantern template over here. Double click that. And if I click somewhere over here, we now have the template of our lamp here. For the sake of this document, I am going to make it, should I make it larger? I just have to rearrange some things because it's all not going to fit on this paper. I can right click, I can ungroup, and now that it's ungrouped, I should be able to click and drag and move the objects around. I can move this object over here, and I can also rotate this at 90 degrees to put it over here. For my design, I'm not going to be changing the top and bottom anyway, so that's fine. move this object over here, and I can use this opportunity. If I click this rectangular piece over here at the bottom, if I click this, it should say the dimensions. And I see the width here in the top left-hand corner is 100 millimeters. So according to my Illustrator file, the size is correct. From my experience, if you try to put this into Fusion 360 and get it back out of Fusion 360, the size might be off. All right, so I have this file, and if I were to cut this on the laser cutter, I would change the colors of everything, but we don't need this for now. I also don't want these words in here because I don't remember if they're going to have a problem with Fusion as they're importing, but I don't need them anyway. I know what thing is what inside my design. But if you have a design where it matters what's the front-facing piece, they are coded in a particular way, as in they interlock with this top section in a particular way. So you might want to keep that and remove that at the very end. So I want some sort of pattern on this, so it's not just a rectangular wall. I'll keep one of them flat so we can see the flat one in Fusion. For the rest of them, I want a pattern. So I just went on Google and I looked up free laser cut stencils, right? And these ones look nice. This is something where it's useful having the laser cutter for a purpose like this, because this design, to do it by hand, would be very difficult. So I want to do this. I have these designs over here, and now I'm going to go one step even easier. I'm not even going to import this file. I'm going to show you how to do an image trace, which you may have done in Year 7. Otherwise, we can do it. I'm going to show you it now. If I'm just going to screen cap this using the Windows keys, and I want this style over here. I'm going to highlight that. And then once I've got this style copied, I can go back to Illustrator. I can press this button. I can press Control V, and now I have this style. I have this artwork here that I can do something with. So actually, I'll take that back. I'm going to do it on a new sheet, just so I can get, and then I'll copy paste it over when I'm ready. I have this over here. Now this is a bitmap, which means this should have, I can't zoom in, right? This will have individual pixels, and the laser cutter doesn't like this. Fusion 360 doesn't like this. I have to convert this bitmap into a vector image. So I can click it. If I click the image, I can go over here on the left, on the right of the screen, and I can press the image trace, or I can go to Object and Image Trace, and I can press the Make button, and it should. Now this object is a vector. If we zoom in, we can see over here the lines are wobbly, sure, but they are very precise lines. If we compare that to what it was previously, that was bitmap. How do I go back now? Forwards. Redo. Okay. All right, cool. So now this is something I can use. Let me just get my zoom out. Too much. All right, so I can get this image, and I actually want all these pieces in the center. So I have this thing over here. I'm going to press the expand button. And so what that allows me to do is allows me to separate, should allow me to, if I double click it, I can separate the individual components. So this over here is the backgrounds of everything. And if I highlight over here, we have, these are the things I want to cut out. Just so I can see them, I'm going to give us a color. Let's just call these green for now, just so I can see it as I move it across the screen. I don't want these two border pieces. But this is the parts I want. I want this part in the middle. So I'm going to hover over it. Shh. Hover over this, and I can copy that with using Control C. Over here, click somewhere. I have this parts that I want to cut out. Now I'm just going to scale the size to something that makes sense on my drawing. I could be very precise here by changing the width and height in the top right hand corner of my screen, but for the sake of this I'm just doing it quickly. And then I got this shape over here. Now let's say I want another thing. What's a meme that's relevant now? Ah, yes. It's not even an energy drink, is it? No. Yeah, we've got to get, yeah, let's make it expensive. So let's say I also want my thing to have prime energy drink onto it. I can right click, copy image, go back to the page that I was on before. This one, let's just start a new one again, just so I can keep the old stencil. Right, I have prime energy drink. Control V. It is huge. Can I change the size of this? All right, it's a huge file, it's a huge image, but also it's got black and white and colors. The first stencil we had was, so the first one we had was just black and white, very simple. This one is a bit more difficult, so I'm going to go to image trace again. Object, image trace, select the object, image trace, make. It's fine, do it, I believe in you, computer. Oh, that somewhat worked, yes. So I have this image over here. Now we'll do the same thing. We'll expand. We'll move the outside. Now this object didn't work as well as our previous one. It didn't work as well as our previous one because this was a real world object. How image trace works is it finds the color gradient from something that's very black to very white, and then it picks a number in the middle, and that's where it makes a line. So since that's the case, I'm just going to try to get this part in the middle. Do I think this will work? Probably not. Yeah, what I'm actually going to do is, so I think the only part that's going to work, I think that's all that's going to work. That's fine. So let's just do that. So these symbols over here, we want, right, this might work, sort of. And then I can also make a shape myself if I wanted to draw something with an art pen or something like that. I could just do a right. This isn't. Look at that artwork. Sheesh. I'm basically the Bob Ross of CAD. All right. So I have this. Now I want to import this into Fusion 360 so I can actually get something. So I'm going to go to File. I'm going to save as. Save this on my computer. I'm just going to save this all onto the desktop. I don't want it to be an Illustrator file. I want it to be an SVG, and I want it to be lantern with stencil. Lanterns with stencil, okay. Now let's go to Fusion 360 while this is saving. Save. We go to Fusion 360. In Fusion 360, I just started a new file over here. Before we do anything, we are going to go to the Insert. If you press Insert, you can insert SVG over here. Something vector graphics, I think. I press down the button, I press Insert from Computer. I go to Desktops, and I should find my lantern with stencil. I've got to pick where I want this. This is going to be like a sketch, so it's going to be 2D. I'm going to press here. Nice. Look, I've got all my images over here. Ready to go. Oh, look, it does keep the text. So we've got to get rid of that. All right, press OK. Give it a minute to be happy with its life choices. All right, so we have these sketches now in Fusion 360. Now, my laptop is relatively high power. All right. When you're importing these sketches, Fusion will do it, but it will get really laggy really quickly, especially if you start to have a really intricate shape. For processing purposes, right, thing with little tiny curves is more processing power than a massive object with a bunch of straight lines. Because Fusion and SVG files in general work on things mathematically. So this line over here, like this thing down the bottom, this 100 millimeter thing over here, this is just 2 lines of maths code basically. It says a line from this point to this point. Doesn't use a lot of memory. While these curves over here, right, these are like, each one of these is its own parabola, or its own, imagine like a parabola but with more terms to it. And so see this is one formula for this line. This is another formula for this line. So as you do this, it gets more and more complicated as you go. Your computer might start lagging out. So what we're going to do is, to get it out of the lag zone as fast as possible, we will actually select, is this not closed? No. Before we do that, notice we have a color difference over here. This one over here is, how would you say, it's like shaded blue. Can you see it on the projector? Right, this is shaded blue, while this one is not shaded blue for the most part. That means, according to Fusion 360, this is not a closed object. There is an opening somewhere in here. Now, I don't know how to find where this opening should be. Oh, is that it? I think I found it. There is a way to close it. We're still sketching. You can just link that. We'll see. Let's see if it loads up. We want to get it out of this sketch. It was, yes. Good. All right, so that's one. That thing would be ready to go. This one, it's probably in the same spot. This is, I don't think this is an error due to, I think this is an error due to the code that we got from that website. That website was actually made by a bunch of people in a hackaday. So they made that the basic part of that website in 24 hours as part of a competition. Obviously, it's been upgraded over the time, but it's not. It's still done by like some dude in a basement on a laptop. So, I mean, I thank them for it, but the code is not the best, as in it does small issues like this. And when you're laser cutting, it doesn't matter. This joint over here is only 0.018 millimeters. The laser cutter doesn't care about that inaccuracy, but Fusion does. So once I close this, it should fix that issue for this side as well. Oh, no, Fusion did not like that, because I'm just going to pause. All right, we're back. Yeah, this is the most temperamental part of Fusion. Do this part in a nice clean document, because when you have nothing else important on Fusion that you need to do, because this is where it's very likely to crash. This is the least safe part of Fusion from a software perspective. It's using a lot of memory. So if you're dealing with a device that doesn't have a lot of memory, this is where bad stuff can happen. We want to turn this now into sheets of actual things. So this is a sketch that's in 2D. By default, when you import an SVG, it's going to be a sketch. I'm going to press the Finish Sketch button over here. So now I can deal with my 3D objects. I'm going to extrude. If I press this shape over here, it's going to extrude it for me. Fusion allows me to select multiple shapes. So for this, I'm actually going to press this as well, and we'll get to Y. We actually want, this is was an artifact of our image trace. Your life will be a lot easier if you pick an image that's already a stencil. Like this one over here to the side was already a stencil, so it made it a lot easier. For this one, I'm just going to press the outside part like this. And, yep. Now I'm going to extrude it. The distance I'm going to extrude is going to be 3 millimeters, because my object was 3 millimeters. So my timber was 3 millimeters, and the cut size with this was also 3 millimeters. Uh-oh. Okay. I'll unpause it when it freezes, when it unfreezes. So if you do that extrusion and it all works, you're now in this phase. Now, once you're in here, most of your problems are gone with regards to the processing power of Fusion. This is what Fusion wants. This is a nice, clean object for it to work with. You can actually move it now, and relatively to before, you can move it as fast as you want, as there's no graphical problems. Because these are all solid objects. Right? This is peak CAD, what it wants. Insert the dubstep. All right, but we don't want this, we want pan, I think. Okay. So these are now my sheets. This is like what it would look like if I pumped this out on a laser cutter. What we can do now, actually doing our design of this, is quite simple now, because we can assemble these together. Let's look at our bodies. We have a lot of bodies over here. If we notice, what's going to happen when I try to cut this? Yeah, it's going to fall off. We can fix this. This is where we're doing some like post work to make it look better. Let's go and let's make like a joining piece. We can either go across, I think vertically looks the best. But, let me show you what I mean. Yeah, we're going to make like a connecting piece so it will hold when we laser cut it. Yeah. It won't look it won't look exactly like prime, unfortunately. But so well, we're going to do something like this. Yeah, it's going to be that. So it should, and you might see this before if you see like signs on like lots of times they graphically do this because they rather it all be on one stencil. This piece over here is 2 millimeters thick, so it's not massive. Final sketch, and this is just if you're bringing in letters. If yours has any wordage, or you have an if you have an image and you have objects that need to be separated, you'd be doing something like this. So now I have this object over here. I'm going to extrude. I'm going to select these shapes that I just made. Now here's the issue. I can drag it over here, right? I can make an object this way, right? No problem. But I actually want it to connect to the other piece. So as I go backwards here, and I don't want to go minus 3 millimeters, because that's how thick the temple is, this or is it 3? Oh, I did minus. So this symbol, right, of the redness that you see over here means Fusion is identifying that you're extruding a sketch through another object. It assumes you want to cut. So because it assumes you want to cut, that's what it's doing. We can fix this over here under the operation area. Instead of cutting, we want to join. So now we can make these are going to be the same object. All right, and so now if I press OK, that's what we're going to get. Right, it's obviously not exactly the same as the Prime logo before, but all things considered, the message gets across, and it's a nice way that you can actually get this to work on your lamp now. This will work. All right, now let's actually start building this lamp. We have, in Fusion, we can move our objects around. We can press this tab over here, move and copy. So I can move this, I can click this shape over here. I can select it. I want to make sure that I have bodies selected. And now I can, oh, that's pretty hectic. I can, and for this, can I get into 3D space, please? No? Still a bit laggy. Okay. This object over here, do we see how these arrows and planes things, these relate to how we want to translate it? If I move it in this place, I can move my object in this direction. I can move it, this plane does it in that, in the YX plane. I can also rotate it. I can, over here, I can rotate it 90 degrees. So I could manually move it to align it up together, right, and then start making my box. But there's actually an easier way for us to do this. These things should all mesh perfectly because, well, as good as they can get based on that stencil thing we had. So we're actually going to use this tool over here. We're going to use the Align tool. So if we look at the image on the Align tool, we get two faces and we can match them up together. So align. So we actually want to align, if my maths is correct, this over here, this shape should align with can I it should align with that shape over there. But we want it to be flipped, and we want it to be rotated at 45 degrees. So now these shapes Did this work? Let's see. There we go. It has automatically lined up. Now, I think there may be an issue with this. I think there may be an issue with this sketch because I just want to test something. Inspect. If I inspect the length of this part over here, that should be 3 millimeters long. Yep. The gap over here should also be 3 millimeters long, but it's 2.1. I'm going to go back to my sketch that we had at the start, and remember how we did that line to measure? I should have actually checked first to see if that line is actually 100 mil. That original line we had there was 87.7 millimeters. So this is an uh-oh spaghetti-o moment. Yes. So that meant it wasn't large enough. So what I will do, what was the actual length was, what was it? 87.75, okay. 87.75, so what I'm going to do is, I'm going to go my history tab, I'm going to bring my history tab back to here. Scrolling my history tab back, we're in this phase over here. I actually want to enlarge my drawing. What I'm going to do is I'm going to create, edit sketch. In this sketch, I am going to, where's the scale button? Sketch scale. Right. I'm going to select all the entities I want. I'm going to select a point that they're all going to scale by, so let's just make it the origin. And if I go down here, I have to pick what scale factor. So my original size was 87, and I want it to be 100. How much larger does it have to be? Anybody? Matt? Anybody? Maths extension? If your original size is 87.7 and you want it to be 100, how much larger does it have to be? 0.2, what? Well, we're lucky that we can put in formulas inside our thing. 100 divided by 87.75. 87.75. I can actually put that number in, and then if I press OK, if it works, come on, we should get that scale in. Now, if we inspect this element over here, oh, what? Why didn't the scale work? Uh-oh. All right, instead of doing it in the sketch, for those that were here, instead of doing that through the sketch, I did it outside of the sketch. So I used the modify thing over here, and I just used this scale over here, and I selected the whole sketch through here. And that seemed to work, because when I measure this element over here, we get a length of 99.999, which is close enough for us. And then we just do the same steps again. Now we can, we don't have to change any of our previous actions for the extrusion. That should just work. We might need to change the location of our sketch for the crossbars. So we'll change that. The parts that were holding like the middle of the P. The supports, yeah. That's what I meant. Come on. So we'll just make that again. We will. And remember, we have to make this join. All right, so I think now we're ready to start combining this to make it an object. So we're going to be using the align tool. So let's go and actually use these top pieces to do the alignments, and so we can align everything to this. In this case, we want this face is going to be aligned with this face over here. It's going to be flipped, and it's going to be rotated. There we go. That's going to be our top piece. Okay. And then we can continue doing the rest. We're going to align this with that piece. Flip. prime is the wrong way. Maybe I'll shine up onto the room. Yeah, I should have done it the other way, but I'm not going to fix it now. I should have aligned it to the other side. I guess this is one of the reasons why you should pay attention to the like which side goes where. All right. For the sake of this rendering, I'm not going to bother with the bottom part. Oh, should I just put it in? Yeah, why not? Let's finish it off. Come on, zoom in, please. There we go. All right. So this thing is done. Now we have our tower and we've put it into Fusion. All right, let's do, we're not going to make it out of this material. We're going to make our tower out of wood. So we can just actually highlight it. We can right click on the tree on the left. We can change its appearance. Now there are actually different styles we can go for here. Selected everything. If we go to wood, there's two types of wood, and I spoke about a bit in the previous task. Okay, there are two types of woods in this thing. One of them is just like an exterior colourful wood, like if you imagine like the graining you get on tables and such. If your object has just exterior components, that's fine. You can also do what's solid wood, and what solid wood will do is when you look at a standard piece of timber, what you visually see when you look with the grain is like long, thin lines that are pointing in one particular direction. But if you look at the end of the plank of wood, you'll see what looks like rings or part of rings. You can do that in Fusion. It actually has a solid option that'll do that. We can load up over here, we can get solid woods. Let's say we're getting unfinished wood out of the laser cutter. Our plywood is pine. So I can just click over here. I can put pine into my project, and I should be able to go over here, drag pine on all our pieces, and it will start turning it into that material. So if we zoom in, see how we have that different artwork? So it's making it look more realistic. It doesn't have plywood, so that's just something we got to artistically accept. It will also try, I believe, to guess what is the better side of the timber, which is like the side that has the long thin lines. I believe Fusion will try to predict that by whatever's the largest flat surface, which for these flat packs, it should easily detect it. If you're making a thing out of a solid cube of wood, it might be difficult for it to determine which one. I don't know if there's an option to manually change the orientation. There might be. You'd have to Google it to find out. So we have these things over here. Now this thing in theory could render straight away, but before we do our rendering, we need to get some sort of light source. So to do this, we are going to we're just going to make like an LED. We're going to have like LED lights shining. So what we'll do is we'll go to Sketch. We're just going to pretend we have the lights shining up from the bottom. If I do this sketch over here and it loads up, we will just do a regular rectangle, or square. All right, we'll just do a square like this. We'll press Finish Sketch. Now, this is a common mistake people have on Fusion, so I'd like you to watch this carefully, please. I have drawn this sketch on that piece of timber. If I go to extrude it, if I click that sketch and extrude, by default, if it's actually touching the piece of timber, it might want to join. All right? We don't want this to be the same piece of timber because we want to make this like a light source. It's going to be emissive. So we have to make sure that it's a new body when we make this. All right? If Fusion detects you going into another piece, it's going to assume you want to cut. If you extend from another piece, it's going to assume you want to join them together. But if you just want to have two pieces that are next to each other, you have to make sure that that setting says new material. So new body. All right, an appearance over here. Uh-oh. Did it join them together or did it just freeze? Did we lose all of our artwork? Oh, lovely. Oh, maybe it just doesn't do it in appearance. Okay, so for this we want miscellaneous. No, not miscellaneous. Where is it? No, not physical material. Sorry. We don't want physical material. Physical material, this is technically all aluminium because that's the default material. Or is it steel? Doesn't matter. This is more for when you're doing simulations. My mistake. I should have right-clicked and pressed appearance, not physical material. if I press appearance and it loads up, we want to find miscellaneous, emissive, and we can just get a bulb. Or we can get an LED. We don't know exactly which type of lumens our LED is, but we're going to assume our LEDs are cheap. So we're going to pick 8 lumen LED. I can highlight over there, that thing's going to be emitting light now at a particular rate. I press close. Now the magic's going to happen. Before we do anything else, I'm going to save my work. Not CNC cars. On the table, please. 2023. I'm going to save my work because, as we know, Fusion likes to crash a lot, and at this point, we've spent almost the whole double lesson doing this. Don't want it to crash. I'm not going to laser cut it, no. Why? You have to change the colors to like red and stuff. We can do getting it ready for laser cutting. Add another. We'll do some renderings and we'll see. But this is ready. We can see by the file name has changed over here to 2023 lamp 1. Right, this is all good. Now let's go do some rendering. We spent all this lovely time making it pretty and aligned. Now we have our lamp over here. We want to get that sponsorship deal, so we're going to arrange it to look like this. Right, that's our lamp. Over here, can we also set up an environment? We can put a scene, I think. Environment, yeah, let's give us an environment. What environment you got?
On the street.
Oh, on the street, yes. Beautiful. You might be able, if you search the web, you might be able to find environments that look like living rooms or bedrooms. And then you can put those in. I don't know what template, there we go. Beautiful. Yeah, there's probably some of these environments that are this, like attach custom environment. Some people may already have one. Have a search to see if there's one that exists already. Let's say I'm happy with this particular setup for my thing. I can then go to render. Now you're given a few options over here for rendering. Because you're on your student accounts, you can use cloud rendering. Cloud rendering means you're shipping this file to the servers in Seattle for Autodesk. They have big render farms, like big racks of computers that just render this stuff because not everybody has the high-tech rendering computers. For this relatively easy render, you could do this on your laptop yourself. I would recommend you have your laptop plugged up to power and don't play any video games while this is happening because it's going to be using all your processing power. Even though you have unlimited, you're still allowed only a certain amount of renders at a time. It's to stop you flooding the render bank with a bunch of renders. What happens here? You have different size. This is usually based off the window that your computer is at right now. You can change your aspect ratio. You can change your settings over here depending on what you want your artwork to be. For the sake of your report, just get this and put it into what makes sense in your report. Or I believe you can save it as a JPEG as well. So cloud render, you send it to their computers. Local renders yourself. Final is going to put more time in the rendering. Let's just do standard for this sake because I want it to be faster. And then if I press render, it should start rendering the documents. Once it starts putting the rendering on the queue, I'm just going to pause the video so the video doesn't have to wait the time. When you see this thing over here, that means it's rendering. It's sent to the place, and the place is rendering it for you. It's been submitted. while this rendering is happening, if you click it over here, it says your job is currently in the rendering queue, so it's going off to the computers. Shh. We have our image over here. Now this is not exactly the same as the one we had in Illustrator, right? For example, we put those supports for the P's, right? Or let's say you change a bunch of designs, you decide to modify it in Fusion for some reason, which you could, like, there isn't a hole, I might want to make a hole at the bottom for a cord to stick out or something like that. So I actually, stop talking. I want to get this file back into Illustrator because Illustrator is how I send it to the 3D print, the laser cutter. So this face over here is actually different. So what I can do is, I'm going to hide all the other bodies for now. This one over here, I want to get this surface so I can send this surface to Illustrator. If I click on this surface and right click it, I can press create sketch. Give it a second to load up. And if we look on the left-hand side, there should be another sketch popping up here, sketch number 5. Now I'm not going to do anything. I'm just going to press finish sketch. I've made the sketch, but I haven't changed it. If I hide this, we'll see what happens. If I hide this, can we see how there is still the sketch here that has all the detail of that flat surface? Now note, you can only do this if the surface is completely flat, because sketches have to be on flat surfaces. But now I have this sketch over here. I can right-click this sketch. I can save this sketch as a DXF file. A DXF file is another vector file that can be accepted by Illustrator. So save it as a DXF. Let's go desktop and let's say new prime. Save. I can then go to Illustrator and file, place. We go to desktop, we find the new prime DXF that we got from Fusion 360. Show import options, place. Should be fine. Okay, yep. And then if I pick somewhere to place it over here, we'll worry about the actual sizing later, because I will have to adjust the size when it comes in from Fusion. But we see here, this one has the new size. It has the cross parts that we made in Fusion. The scale is off, right? This piece is not the same size as this over here. So I'd have to do the same function. One thing that we have going for us here is we know what the size that we need this one to be because we can hover over this. If we hover this, we know the size has to be 100.2 by 300. So if I do the same thing here, if I hover this, I can change its size to, its width to 100.2 and its height to be 300.2. There you go. So now this thing, granted it's inverted, you could probably flip that with this over here. Flip, there you go. So now you can import your shapes in from Fusion. Now to take it to the laser cutter, all we'll have to do is get the colors that we want for this particular one. I deleted the one from Fusion, but you could keep it if you want. We have to highlight it. The rule for our laser cutter is it has to be RGB red if you want to cut something completely, and the thickness has to be 0.001, and there has to be no fill. Now it's difficult to see because it's so thin, but this now would be ready to take to the laser cutter. We would get this file, I'd save it, put it on memory stick or email it, load it up onto the computer in the laser cutter, and this can start cutting out that shape. Let's see if our drawing, if our rendering is done. Oh no, before we do that, I like this lamp, but let's say I also now want to make it look like it's on a desk or something. So I've actually downloaded some objects. How do I put them in? Insert. Insert mesh. Let me look at the downloads file. Okay, I downloaded this from a website, which I'll show you where the website that we got this from, but I don't have the link yet. I'll put the link on after this video. But if I open this up, over here, look at this. We have a coffee table already pre-made. If I were to put this into my report, I would have to make a note that this obviously is not my work, right? I don't know the exact scale of this thing, and I don't know the exact coloring, but now I'm already building an environment for my lamp to fit on. I can use my what can I do? I can move. Does that work? Yeah, that works. Okay. So I could get this object now, and I could choose right. I have this object over here. I could then, so that's where my lamp's going to be. I could also send this now, if I save this, I can send this object to my rendering as well. Some files you have already have colors and stuff put into them. Fusion is not the best at that, because Fusion is meant more for an engineering perspective. But it's also fine for creative purposes to pick this background to be a very dull color, because you don't want our object to be confused in it, or in this case, all metal. Good. While I'm setting this one off to render, right, so that's our lamp over here, just chilling. Oh, now we have a bench in the middle of the plaza. We could do the same thing. We could render, and I'll send this one off to the cloud as we look at our job we had before. So this is the one we did before. Let's have a look at how the lights and stuff work. All right, there we go. That's a decent looking lamp. How we can improve on this? You can also put another sheet of material inside it, because you're going to put, like, if you put like baking paper or some sort of parchment paper to diffuse the light, you can do that as well. We can add a piece in there. There are objects we can do. Let me try that. Actually, I think we have time. Let's go to design. For this design, I'm going to hide the table. We don't need the table for this render. Let's say for this one, I'm not going to do it in all directions. I'm just going to do it behind this sheet, and obviously you can do better. You can do more on your design. So I want to sketch over here. I have a feeling the bell's going to ring before this is going to be done. And my computer's on power recovery mode as well now. I might save this part for another lesson. But we've got that rendering, and I'll show you the result of the rendering at another time as well. Yeah, I'll actually close this. Has this render been done yet? No, the rendering's still happening. All right, I'll show you the results of that rendering at another point. But that's it for this tutorial. Let me stop.